Hello! Today I'm going to start by making good on the promise of showing you some SpongeBob references. So I'd like you to take just a moment or two to take a look at these Patricks here and decide which Patrick you are feeling today. Okay. I hope you are not number 4 or number 2, but even if you are, that's okay. Please bear with me. I promise I am going to bring this back in a few slides. Today, the lecture topic is research methods. In this lecture, there is going to be some repetition of content straight from the module, right from the textbook. This is not something that I do typically, but remember the extra principle by which I give my lectures. I lecture on things that are extra difficult, extra important, or just plain extra, right? 3 things. Turns out that there's a little bit of all 3 in research methods. By students' own reports and by my experience in grading students' exams, I can tell that research methods is one of the more difficult parts of the course. And it's extra important. Research methods is the foundation upon which everything else in psychology is built. It's the reason why we know anything with a capital K in psychology. And then finally, there will be just a little bit of extra here, and I'll tell you where that extra is when we get to it. So first, let me start with one of my favorite things to say that I think my dad is the first one that said it to me. There's only one reason why you are allowed to say something is true in psychology, and that reason is someone did the research. Not just one someone, lots of someones. This is what it means to be a science-based discipline. This is one of the most important topics that we're going to study this entire semester. Right? Solid research methods underlies everything else in psychology. So, outline for today. We're going to start by talking about science and psychology. Is psychology a science? And what does it mean to be a science? Then we are going to begin talking about research methods in context. I'm going to be splitting up research methods into 2 videos because I don't want it to be overlong. So today we will start the research methods in context and I will finish it up for you in another video. So let's get started talking about psychology and science. Major question, is psychology a science? And supplementary question, why should it matter? Answer, yes, and because I said it matters. But that doesn't feel so good, right? That's really unsatisfying. So let me explain to you. Give me some reasons why it's a science and why it matters that it's a science. The first reason why this matters is very, very practical. US News does puts together a list each year where they survey careers based on salary, unemployment rate, the future prospects, and the stress level of each of these careers. And they compile them in the list of 10 best science careers. Let's take a look at those 10 best science careers. Oops. Okay. So number 1, this is from 2023, you'll see. Number 1, epidemiologist, medical scientist, not super surprising there. Biochemistry. Number 3, psychologist. Okay, let's keep track of these. Number 4, industrial psychologist. That's 2. Forensic science. Survey researcher. That's 3. Anthropologist. 4. archaeologist, 5, geographer, I only have 5 fingers on one hand, but 6. Okay, so 6 of the top 10 science careers are in the social and behavioral sciences, right? The types of sciences that many people don't think of off the bat when you say science, right? They think of things like biology, physics, chemistry. Psychology is absolutely a science. These social sciences are absolutely sciences. That's important. Okay, so that's the practical reason why it's important that psychology is a science. The second reason, this matters because science is important. See, you can tell because I put important in a different color up there. Historically and currently, science is one of the most respected ways to discover the truth about something. In fact, I sort of feel left out that psychology is often not in the STEM department, right? We are absolutely a scientific discipline. All right, now, what if you are not a STEM major? You're not even a major in the social sciences. You don't want one of those top 10 best science jobs. Science is still important to you. One of the definitions of critical thinking that I really quite like is thinking like a scientist in your everyday life. Let's go through how this can happen. In real life, you make predictions all the time. Why do I drink so much coffee? Because I think it will make me feel more alert. Or if I have to teach through what would usually be my snack time, sometimes I will drink coffee to help myself feel less hungry while I'm teaching, right? That's a prediction. When I'm making a new friend, what kind of jokes is this person going to laugh at? Do they like puns? Do they like crass, offensive humor? I'm going to make some predictions about what jokes this person is going to find funny, and then in order to try to befriend that person. After I make predictions, I'm going to make some observations. Do I actually feel more alert after drinking coffee? Am I actually able to get through my classes without eating a snack? Does this friend laugh at these rude jokes that I'm telling, right? I need to observe what happens. In science, these observations should be unbiased, right? This is very different from the unscientific approach where we have to strive to keep our personal biases out of the way. Then, and only then, can you draw conclusions. Oh, my friend laughed at that really offensive joke that I told, so she must think that that kind of stuff is funny, right? However, I need to actually, maybe this should say draw tentative conclusions, because these conclusions should always be willing to be revised and improved if more data comes along or better data comes along, right? If my new friend actually stops me and says, you know, I really didn't like that joke that you told. I only laughed because I felt uncomfortable. That should make me revise my conclusion, right? That is more observations from the real world showing me, oh, actually my conclusion was wrong. I need to revise that conclusion. This is an incredible way to behave and to live your life. Right? Do you like to be right? I absolutely like to be right. Thinking like a scientist in your everyday life is one of the ways to have the highest confidence that you are right. Let me give you a brief real-world example. Over the course of the last few years, lots of people criticized the quote-unquote constantly changing advice from scientists about the best way to stay safe and healthy over the course of the pandemic. Some people accused scientists of lying, right? They noticed that at the beginning of the pandemic, the advice was that masks don't really work, they don't help stop the spread of COVID. But then scientists advised, oh, actually, yes, masks do help. They help keep you safe. They help keep other people safe. So we should be using them to help stop the spread of COVID. These individuals, or the scientists, they were not lying, right? The science is not a static collection of facts and procedures. Science is a process. Science means you need to be open to changing your mind if better information comes along. We have been learning about COVID for years now, right? At the start, someone did some research and found one thing, that masks didn't work. Then, later on, more someones did more research and found something different, that masks are helpful. This is science working in the way that it is intended to work. So this is not just for scientists, this is also for your daily life. There's a problem, though. If your experience with science so far is just science classes in high school or maybe even college, you could be forgiven for thinking that science is kind of boring, right? I remember very, very vividly sitting in my high school chemistry class, just bored out of my mind. We had to do things like add 7 milliliters of solution A to solution B, then stir clockwise 11 times, counterclockwise 2 times, heat it to 189.7 degrees Fahrenheit, and then do a little dance. No, not that last part, but you get what I mean, right? Just a bunch of random things that made me think to myself, what is the point of this? Why on earth are they making me do this stuff? It felt like they were just teaching me how to follow directions. I know the reason for that work now. It's called instrumentation. Instrumentation is a very basic skill that you need to learn if you want to be a chemist. You need to learn how to use the instruments in that discipline, right? Measuring things, stirring things, heating things up. You need to learn those. But nobody told me that at the time. Science just seemed pointless. But dude, science is super, super cool. This burger that you see floating above my head here, this burger has no meat at all. Now, I haven't had an Impossible Whopper, but I have had Impossible Burgers, and I think they're pretty good. My meat-eating friends that have had Impossible Burgers, they also say, well, it's pretty good. Can you believe how cool it is that someone made a complete, like an artificial plant-based substance taste like a burger? You know who made that? A chemist. A food chemist. This is cool, right? And more than cool, this is really, really important. If you are a meat eater, one of the major things that you can do in your personal life to reduce the impact that you have on our changing climate is to eat less meat. So science, in addition to being super cool, is also solving very important real-world problems. Okay, maybe you're not into food chemistry. The goal to make science learnable is to make it interesting. something that you are curious about, something that you care about. For example, what is the most effective treatment for depression? I am going to come up with a context to talk about research methods that I find interesting and meaningful. But if this context does not work for you, I strongly encourage you to think about another context that you do think is interesting. So, here's my context. For my entire life, I have loved school. I was one of those admittedly kind of dorky kids that enjoyed going to school. I loved getting assignments and reading that I got to do at home. I liked getting better at my assignments over time. I just loved everything about it. My brother, on the other hand, Doug specifically, really did not like school. Here's two pictures of him. The first one is of Doug as a child, and then the second one is Doug in 2020. He's the one in the red shirt. He looks a little bit different nowadays, I'll admit. This always was something that really, really interested me, right? We grew up in the same family. My parents read Harry Potter to both of us each night. Why did that happen? Why did some kids like me end up loving school and other kids like Doug ended up hating it? Unfortunately, it's more than just my brother. A recent survey asked 20,000 US high school students about their feelings about school. Over 75% of the feelings that these students reported were negative. Tired, stressed, bored, right? Those are the three main things that people mentioned in this survey. And maybe you feel some of those emotions about school too. Let's go back to this "how are you feeling today" question that I asked at the beginning of the lecture. Now, obviously, I can't collect data from you right now because this is a lecture video, but when I have asked this to in-person classes, or when I've asked this to hybrid students that are later going to be joining me online, many people pick number 4. This is really depressing to me. One of the things that I really hope comes across about me is that I love my job. I love teaching. I love being with students. I love talking to students. And I love interacting with students. So this context of talking about research methods and applying it to school, that makes it really interesting to me. I want to know why this is. Why do some students have such a poor experience, and why do they hate school so much? Okay. So when I connect research methods to this context, I find it very interesting. I'm going to talk about some of the research methods material from Module 2 in this meaningful context. Today, I'm only going to have time to talk about a case study, but in the next video, we will move on to surveys and correlations. I will connect that video to some information that you gave me in the pre-course survey, and then finally, I will probably have time to talk about an experiment in the next video too. All right, let's get started with the case study. This is something extra important. Why do people like or dislike school? Let's pretend for a moment that no one has done any research in this question before. They have, but for the moment, we'll just pretend. If you're in a brand new domain, you need to generate a whole bunch of ideas. So one way to do this is to take one individual person and study them very in depth. This is a case study, right? Let's take, for example, my brother. you would interview him. So, Doug, tell me what school was like for you when you were in elementary school. He would probably say something like, well, super boring. My teachers weren't that nice to me. I really hated having to sit still all day. I hated that I couldn't sit near my friends. We didn't ever read anything good. I really didn't like that my teachers would always tell me what to do. I never got to choose how I spent my time when I was in school. You would interview his teachers, so ask them, okay, how was Doug in the classroom? Did he respond well to authority, or was he a little bit rebellious? You would also interview my parents and ask them how they felt Doug was as a student, right? If this were a real case study, you would also want to follow him around live and see how he interacted with people in the classroom. You get a lot of really rich, detailed data about this single person when you do a case study. And this is excellent, right? This is excellent for exploring a new topic, for generating some new ideas, and for understanding something complex in context, right? I can study the relationships between this one person and his family, this one person and his teachers, his school friends. All of this rich information I get from studying that one person. However, there is a major limitation of case studies. This is the extra important part. You cannot generalize from one case. I mean, what if Doug is weird? He is weird, but what if he's weird in this respect specifically? What if he doesn't like school for a weird reason and other people dislike school for different reasons, right? He's only one person. You cannot conclude anything about other people in general just from one person. Importantly, this may be a case of inert knowledge. Knowledge that you sort of know, but you can't apply. If I were to ask you a question on a test, what is a major limitation of a case study? If you're watching this video, I would say most of you are probably going to be like, oh, got it, cannot generalize from a case study. And you will get that test question correct. But those very same people might turn around and make this mistake in their own lives. When you draw conclusions from your own experience, you are generalizing from a case study. Every single person is a case study. Just because something is true for me does not mean that it is true for you. And it might not even be true for me, right? That's why you've already learned about biases that can cloud our thinking, like overconfidence, false consensus, confirmation bias. There are all these reasons to suspect why our memories of things are actually not perfect recreations of what really happened. It is very likely that many, if not all of you, will have the following experience over the course of the semester. You will read something in the textbook, or I will say something in a lecture that contradicts your own personal experience. There are things that you can and cannot do when that happens. One thing you can do, and I encourage you to do, is to question that, to say, that's weird. I wonder what's going on. Is there something different about me? Is there something different about the research? Right? Because everything that I tell you and everything that you see in the book is based on research. Here's one thing that you cannot do. You cannot just immediately reject the research and say, oh, well, the research must be wrong because my personal experience says something different. What do I mean when I say you can't do that? I mean, well, don't you like to be right? That's the point of research, right? If you want to take a look at the research, if you want to talk about how your personal experience differs from what we're seeing in the course, I think that's an excellent avenue for conversation. But I don't want you to reject it out of hand, right? Respecting and following research is one of the best ways to be right about things. And I want you to be right. Okay, and then one final thing to say about this. Are self-references the same mistake, right? So remember these self-reference examples that you are supposed to be collecting throughout the semester. Isn't that the same thing? You're coming up with an individual real-world example of the concepts that you see in the textbook. The answer to that is no. With self-references, there is a different goal. With self-references, the point of a self-reference is not to prove a concept true or false. That is the point of research. The point of a self-reference is to connect the concept that's already been validated by research to your personal life and experience. Okay, so that's it for today. I hope that you got a little bit of information about why science is so important, why psychology is a science, and a little bit of a beginning on some of the concepts from research methods. In the next video, we will pick up right here where we left off.